So for problem number 1 in this section, I would use theorem 716 because I can see that it's a circle, and then there's two lines going into the circle, so, and they both lead to the same point, which is A. And so just to transfer what's in that theorem to this particular problem, I will recognize that the length from A to C times the length from A to B has to equal the same thing as the length from A to E times the length from A to D. So that's again just transferring. Instead of using P, I'm using A, and then the other points, I'm just using the corresponding points. So now I can just fill in what I do know. So the length from A to C would be x plus 4. So whatever x plus 4 is, so I'll just type in x plus 4. And then the length from A to B would just be x. So times x has to equal the length from A to E, which is 5 plus 7, so that's 12. So just say equals 12 times the length from A to D, which is 5. So when they say this segment, and if you read in here, it says, you know, if two secant segments are drawn to a circle to form an exterior point, then the product of the measures of one secant segment. So it's just the length of that segment. That's what AC means, the length from point A to point C. You can get that just by adding together those two parts. And now you can solve this equation. So I'm first going to use the distributive property, so I end up with x squared plus 4x equals, and 12 times 5 is 60. And then I would probably go ahead and subtract 60 from both sides because I like to set it equal to 0, although there's lots of different ways to solve this. I would probably go ahead and solve it by factoring if possible. So you could graph it and look for the x-intercepts. You could look at a table or chart. You could use the quadratic formula. There's tons of ways of doing it, but I know that my product has to be negative 60 and my sum has to be 4. And so I'm just going to look for numbers that when I multiply them together, I get negative 60, and when I add them together, I get 4. So what I usually do is I just look at, okay, well, 6 times 10 is going to equal 60. So one of those things would have to be negative. Now, in order to get it so that when I added them together, they equaled 4, the negative thing should probably be the 6. So negative 6 times positive 10 is going to give me a product of negative 60. And negative 6 plus 10 is going to give me a sum of 4. So that's how I'm going to go ahead and factor these. So I know it's going to be x, and I'll put in minus 6 times x plus 10. And now if I were to use FOIL on that, x times x is x squared, 10x minus 6x is 4x, and negative 6 times 10 is negative 60. So now I can go ahead and solve each one of these. So either x minus 6 has to equal 0, or x plus 10 has to equal 0 in order for that to be a true statement. That means x is 6 and x is negative 10. Well, having a length of negative 10 makes no sense whatsoever. So that one I am going to ignore, and I'm going with the x equals 6. So that's all I had to do was solve for x on that one. So there's my final answer, x equals 6.